All right, so continuing on with these intro to Trig videos, I'd like to go through this worksheet. I also emailed you a copy of it, so if you wanted to try it on your own first, you could, and then kind of take a look at the worked solutions, or you can kind of view it more as kind of an overview before you tackle these kinds of problems in ALEKS. But anyway, just to kind of touch base on a couple of these different topics that you'll see. So for one, I'm just going to kind of run through these examples and explain how to approach them. So I'm going to pull up my little workspace because it's a little easier to work in here than it is to work on the PDF. Okay, so the first one, find an angle between 0 and 360 degrees that is coterminal with negative 432 degrees. Okay, so coterminal means that the angles share a terminal side of the angle. So basically what we want to think about, you know, how we talked about an angle in standard position, this would be the initial side, and then we would have the terminal side. If we call this our angle, this would be the terminal side. So if you think about it, an equivalent measurement would be to go around once and then stop again. That would be considered a coterminal angle. So for example, if our first theta, this angle, was 30 degrees, an angle that would be coterminal would be if I went around once and then stopped at that same terminal side. So what would the measure of the red angle be? It would be 30 degrees plus 360 degrees. So that would give me what? 390 degrees. So we could say that 30 degrees and 390 degrees are coterminal. So if you think about it, when we're thinking about those angles on the XY plane, again, if this was, you know, a 30-degree angle, again, you know that sine of 30 degrees is 1/2. Well, then also, if we think about going around, you know, finding a coterminal angle, so something like this, which we just said was 390 degrees, sine of 390 degrees is also 1/2. And again, that's consistent with what we were talking about in one of the earlier videos, that sine of 390 degrees would actually have a reference angle of 30 degrees. We know that sine is positive in quadrant 1, so again, sine of 390 degrees would be equal to sine of 30 degrees, which, like we just said, is 1/2. So if I'm looking at find an angle between 0 and 360, so that's basically an angle within one revolution that is coterminal with negative 432 degrees. So since this number is smaller than 0, this is an angle, a negative angle, basically all I need to do is continue to add 360 degrees until I'm within 0 and 360 degrees. And really the easiest thing to do, I think, is to grab a calculator. If I take, you know, negative 432 degrees, and now I'm just going to add 360 to it. So that takes me to negative 72 degrees. So again, a coterminal angle, but it's not within 0 and 360 degrees. So I'm going to add 360 again until I'm inside that range. So that takes me to 288 degrees. So 288 degrees is coterminal with negative 432 degrees. And again, that's in between 0 and 360. So 288 degrees is the answer, a coterminal angle between 0 and 360. Okay, so similarly, I wanted to look at one with radians. So find an angle between 0 and 2 pi, so again, within one revolution, that is coterminal with 9 pi over 2. All right, so let me grab my workspace. So coterminal with 9 pi over 2. All right, so again, what does 9 pi over 2 look like if I plot it on the xy plane? So 9 pi over 2, this is going to be more than one revolution, right? So if I think about what is 2 pi with a denominator of 2, that would be 4 pi over 2. And we're looking at an angle that is 9 pi over 2, right? So 2 goes into 9 how many times? A little over 4. So we're looking at an angle that is more than one revolution. So I'm going to subtract 2 pi until I come up with an angle that's in between 0 and 2 pi. So if I take 9 pi over 2, I'll subtract 2 pi, or 4 pi over 2. So that gives me 5 pi over 2. Again, still more than one revolution. So I'm going to subtract 2 pi again. And that takes me to pi over 2. So pi over 2 is an angle in between 0 and 2 pi that is coterminal. Again, it shares the terminal side of the angle with 9 pi over 2. So again, 9 pi over 2 would start here. And I see it actually went around twice, right? I subtracted 2 pi twice. It was this angle. So then to come up with the coterminal angle that was within one revolution, I subtract 2 pi twice, which gave me pi over 2. So pi over 2 is the answer there. All right, number 3, suppose that the point square root of 2 over 3 comma y is a point in quadrant 1 lying on the unit circle. Find y. Okay, so what we're being asked to do here, again, thinking about the unit circle. So if this point is in quadrant 1, all right, so again, sketching the unit circle. So we're looking at a point in quadrant 1, and I know that these are the coordinates, and I'm being asked to find y. Well, remember an equation of a circle, and specifically unit circle, where the origin is the center. The equation of that unit circle is x squared plus y squared equals 1. So I know what x is. X is square root of 2 over 3. I'm looking for y. So I'm just going to make that substitution to find y. So in for x goes square root of 2 over 3 squared plus y squared equals 1. I'm just going to solve for y. So let's see, square root of 2 squared is 2. 3 squared is 9. So let's see, we'll have y squared is equal to 1 minus 2 over 9. So y squared is equal to, let's get a common denominator, so this would be 9 minus 2 over 9, or 9 minus 2 is 7. So y squared is equal to 7 over 9. Take the square root of both sides. And y would be equal to plus or minus the square root of 7 over 3. Okay, so let's take a look at this question again. This says this point is in quadrant 1. So if the point is in quadrant 1, then both the x and y coordinate would have to be positive. So my y has to be positive. So to answer the question, y would have to be equal to positive square root of 7 over 3. Okay, so those aren't too bad. Remember that the equation of the unit circle is x squared plus y squared equals 1, and then when you're given a piece of that point, it's not too difficult to find that missing coordinate. Okay, find the terminal point on the unit circle determined by, you'll be given a specific angle. So since we've already come up with a full unit circle, we've talked about how to derive that, how to memorize deriving that. If that's what you choose to do, the easiest thing when going through these topics in ALEKS is to keep your unit circle handy. So find the terminal point associated with 3 pi over 4. So remember, where is 3 pi over 4? Make this a little smaller. All right, so where is 3 pi over 4? Is right here. And so the associated point is negative square root of 2 over 2. Square root of 2 over 2. If I'm looking at 210, again, here's 210, what's the associated point? That ordered pair is negative square root of 3 over 2, comma, negative 1/2. All right, in number 5, suppose that theta is an angle in standard position whose terminal side intersects the unit circle at this specific point. So now find the exact values, and you could be asked to find the exact values of any of the 6 trig functions. We're just going to pick out 2 of those right here. So remember that the x coordinate is cosine theta and the y coordinate is sine theta. So in this case, cosine theta is equal to 9 over 41, and sine theta is equal to 40 over 41. So if I'm going to find sine theta, again, that one is right there. And if I'm going to find secant theta, remember secant is the reciprocal of cosine. So that would be 41 over 9. So again, I could find any of those 6 functions. If I was looking for tangent, I would take sine over cosine. So again, just keeping those numbers in mind and applying them to the appropriate ratio. All right, find the exact values. So this is a little similar to what we were doing before. Couple different ways, again, that you can think about doing this. One is unit circle, the other is kind of a combination of the two, as I mentioned before. So if I'm going to find sine of 4 pi over 3, and again, I think this might be one that we did earlier, 4 pi over 3 would be in quadrant 3. This would be 3 pi over 3, right? So our reference angle would be pi over 3, or 60 degrees. I know that sine is negative in quadrant 3. So sine of 4 pi over 3 is the same as negative sine of the reference angle, which is pi over 3, or 60 degrees. And remember, if I'm looking at my special triangle, this is 1, 2, square root of 3. Here's 60 degrees, so that would be opposite over hypotenuse. So this is negative square root of 3 over 2. Secant of 135. Okay, so secant of 135. Let's see, 135 would be in quadrant 2, and that would have a reference angle of 45 degrees. So let's see, secant is negative in quadrant 2, so this is the same as negative secant of 45 degrees. So thinking about that special triangle, 45, 45, 90, secant, ooh, I wrote a 3 instead of a 2. Secant would be hypotenuse over adjacent, so this would be negative square root 2. And then finally for cosine, or cotangent, excuse me, of pi over 4, so that is, pi over 4 is 45 degrees. So that's quadrant 1 angle where everything's positive, right? So this is going to be a positive value, I know. Cotangent would be adjacent over opposite. So again, that would be 1 over 1 or positive 1. And next, we're looking for the reference angle. And again, you'll see some specific questions in Alex just asking you for the reference angle, and we've kind of embedded that throughout the different things that we were doing. But if you're just identifying the reference angle, again, remember the reference angle is always a positive acute angle that you make with the x-axis. So 5 pi over 6, let's see, 5 pi over 6 would be in quadrant 2, right? So that's this angle. So again, we know that pi over 6 is the angle that is made with the x-axis. So pi over 6 is my reference angle. If we're looking at 315, again, 315 would be this angle. So the reference angle, again, is made with the terminal side of that angle and the x-axis. So this would be 45 degrees. So the reference angle for 315 degrees would be 45 degrees. All right, so that concludes those examples. I hope this helped. Please let me know if you have any questions.